Good evening, friends. Today we are going to discuss about pipelining. Basics of pipelining. Pipelining is a mechanism used to improve system performance in which tasks are executed in overlapping manner. In this technique, the problem is divided into subproblems and assigned to the pipes. Then the pipes operate under the same clock. Pipelining is the process of arranging hardware elements of CPU such that its overall performance is increased. Simultaneous execution of more than one instruction take place in a pipelined process. In pipelining, multiple instructions are overlapped in execution, accepting new input before the previously accepted input appears as the output of the other end. Pipelining is a mechanism used to improve system performance in which tasks are executed in an overlapping manner. In this technique, the problem is divided into subproblems and assigned to the pipes. Then the pipes operate under the same clock. Pipelining is the process of arranging hardware elements of CPU such that its overall performance is increased. Simultaneous execution of more than one instruction take place in a pipelined processor. In a pipelining, multiple instructions are overlapped in an execution, accepting the new input before the previously accepted input appears as an output at the other end. Design of pipeline. The diagram shows the concept of pipelining with multiple stages. Pipelining has two ends, that is input and output end. Between the input and output end, multiple pipes are interconnected to satisfy the functionality. These pipes are called as stages or segments. Between the stages, buffer are used to store the intermediate result. This buffer is also called as pipeline or register interface. Pipeline stages. A typical instruction pipeline is comprised of several discrete stages. Each stage completes a part of the instruction cycle, such as instruction fetch, retrieves the next instruction from the memory. Instruction decodes the instruction to determine the required operations. Execute performs arithmetic or logical operations. Memory access, read or write data from the to memory. Write the result back to the register file. The output from one stage becomes the input for the next stage, passed via pipeline registers. All stages progress in parallel, synchronized by the common clock. Benefit of pipelining: increased throughput. Multiple instructions are executed simultaneously, improving CPU performance. Efficient resource usage. Stage keeps hardware busy nearly all the time, akin to an assembly line. Higher clock rates. Pipelined CPU can run at higher frequency since the stages work on simpler operations within each clock cycle. Challenges. Pipelining can encounter several issues called as hazards, which disrupt the smooth execution. Data hazards. When instructions depend on the result of previous instruction still in the pipeline. Control hazards. Caused by branch instruction altering the instruction flow. Structural hazards occur when hardware resources are insufficient for concurrent stages. Techniques like forwarding, stalling, and hazard detection help mitigate these problems.